Hello, everybody. Today I'm going to talk about lists. I'm going to describe what a list is and the kind of lists that we're going to make later in the course. So first of all, a list is a very, very important concept in computer science, and all programmers, all developers, all CS majors are supposed to know how to deal with lists in the fundamental ways that I'm about to describe. So let's first give a definition of a list. What the heck is a list? All right. A list is a collection of data items that are stored in a sequence. That's it. It's that simple. If you store data items in a sequence, you have a list. Now, a list is called a list because you are supposed to be able to do certain things with it. So if somebody said, here, I've got a list of data for you stored in a list, I should be able to do the following. I should be able to insert into that list. I could insert at the beginning of the list, at the end of the list, some position in the middle, whatever. But if somebody tells me that I've got a list, then I know that I should be able to insert into it. I should also be able to remove from the list. Again, I should be able to remove from the front, the rear, the middle, a position, something like that. All these things are givens with a list. Other operations that are common are clear the list. You should be able to tell the list to empty itself of items. Then you should also be able to ask the list for its size. And I realize that this clear, I get a little glare, so I'm going to move it. All right, clear the list. There are other options with some lists, like checking to see if it's full, checking to see if it's empty. Technically, you can see if any list is empty by asking it, or you should be able to ask it, but some lists are never actually full, like a linked list. Anyway, these are the fundamental concepts around lists, and in order to advance through a computer science program, you need to understand how these operations work on two specific implementations of a list. So the first implementation of a list, in other words, the first kind of list we're going to make, is called an array-based list. The array-based list obviously stores the list in an array. We have been using arrays since our first programming class. We've been using them throughout this semester so far. And typically when we store things in an array, what we do is we figure out how many items we're storing. We make an array exactly that big, and we put all our items into it. That's not technically a list. Although it is an array, and arrays store things sequentially, they do, it's not necessarily a list because we're not inserting, removing, emptying, getting the size, stuff like that. If we have 500 items in our file, for example, we make an array of 500, we put the items in the array is storing the items, and that's just an array storing items. It's not technically a list. For an array-based list, what we're going to do is we're going to create an array that has a certain size, and that size is the capacity of the list, which is how many items it can hold before it's full. Now, in an array-based list, we're going to insert and remove elements into the array, but we're going to make sure that those items are always next to each other so that our array is actually being used as a list. So when we use an array-based list, the array is going to have two sections. It's going to have a part that stores the list, and it's going to have the rest of the array, which is empty and not storing the list, but is available in case we want to put items into it. So that's going to be the first kind we study, and we're going to do that soon. The second kind of list is a linked list. A linked list is a list that is not stored in an array. Instead, it's stored as a collection of things called nodes. That's spelled N-O-D-E, node. Okay. A node is a thing in RAM that stores one data element, and then also the position in RAM, the reference or the pointer, of the next element in the list. So with a linked list, what you do is you add nodes and you put them wherever you want in RAM, but each one knows where the next one is, so they form a linked sequence. So once again, we have this idea of a list, which is the data is stored in a sequence, but they're not stored contiguously like in an array. They're stored in random places, effectively random, and they're linked by these connectors where one knows where the next is. And that's going to be the second type of list that we learn how to create and modify. And we're going to be able to learn how to insert, remove, clear, and get the size of that. And learning about linked lists is massively important because a lot of linked data structures require you to understand how to link nodes together. So things like binary trees, they're very often linked structures. Also, some stacks and queues are just variants of linked lists, and arrays possibly. But also graphs, those are some advanced data structures that you can store, you can build if you know how to make a linked list. And if you don't know how to make a linked list, then you really can't make them. So anyway, that's the concept of a list and what we're going to learn going forward. Can't wait. See you next time.